All right, now, so completing square. It's something that I guess you might be introduced back in Algebra 1, but you should have done it at least a few times back in geometry. Okay, and geometry, I think you did it when you were doing circles. Okay, now we will also do something about circles today. That's why we are talking about completing square. You should also have done it in the beginning part of Algebra 2. And I will be very honest with you that I also did not understand completing the square the first couple of times that I did it. Because to me, completing the square is simply memorizing some steps that made no sense. I remembered it, I did it, and I forgot about them. Does it echo your feeling? Yeah, more or less. Okay. Now, the third time that I learned it, I think it's also in pre-calculus. The third time I learned it, I was like, I realized something. Something clicked. And that something is, I realized why they call it completing the square. I know what is the square they are trying to complete. I know what the completing process is. So to go over what completing a square is, I need you to get a piece of paper. Okay, I need you to do something really simple, and I need you to do something really quickly. Okay. So on the paper, I want you to just if you write small, you can put it 2 columns. Just do something. I want you to do something on 2 sides. If not, just go straight down. Doesn't matter. So what I would like you to do is this. Okay. So I want you to do these 4. And I also want you to do the other 4. Okay. Take a minute or 2. Go ahead. Do these 8. All right. So should be able to do it very quickly. And here's my my very genuine advice. If you cannot do these fast, that is a problem. You need to do them fast mentally. Like you need to know how to look at this and just start saying, oh, it's x squared plus 2x plus 1, x squared plus 4x plus 4, x squared plus 6x plus 9, x squared plus 8x plus 16. Okay, and the next one is it's pretty much the same thing, except that it's the sign that's changed. So minus 4x plus 4, x squared minus 6x plus 9, x squared minus 8x plus 16. Okay, so that was it. Okay, so it's a quick practice, and it's very important that you know all these well, because you need to know when we say completing the square. What is the square that we're completing? These are the square we're completing. We are trying to create this something called perfect square, like this parenthesis square right here, they are considered the perfect square. So now, let's see if you can see the application of the skill. Okay, so here's the thing. I want you to write down. If you have x squared plus 6x minus 2 equal to 0, then we say, all right, can you solve for x by using completing the square? Okay, Now, I'm going to help you to start off. So usually we'll say, let's go ahead and move the 2 to the other side. And what we are trying to complete again, we are trying to make this perfect square. So now the question is, hey, we are missing something right here. We need to add something here so that we can get the perfect square. So, oh, there's 0 already. That would not help us at all. Plus 9. You look at the top, you look at what you did. Because x squared plus x plus 9 is giving you what? X plus 3 parentheses square. Now, but if you add 9 on the left, you must remember that you have to add 9 on the right-hand side because it's an equation. Whatever you do on the left, you've got to do it both sides. So that means on the left, you have x plus 3 parentheses square. The right-hand side is 11. Now, if we keep going to solve for x, we will do the plus or minus square root on the 11, and then we will subtract 3 afterwards. And that's how we do it. Okay, but all I want to focus here is if I give you something not pretty, could you make a perfect square? Okay. You can't. If we could, we would have done it already. It would not be factored out, and no. The thing is, we want a perfect square. I think that's the key point. We want a perfect square. Yeah, we would like even if you can factor out, it may not be a perfect square. So we want a perfect square, and you would know why in just a moment, because when we deal with these shapes like circles, we need a perfect square. Yes. Because we add 9 on the left. It's an equation. Whatever we do on the left, we've got to do it on the right. Okay. Now let's do one more. One more. X squared minus 8x plus 4 equal to 0. Okay, so usually we would put the constants on the other side of the equation. And now we have the same question. We want a perfect square. What are we missing? 16. We say we go ahead and add 16 on both sides. And therefore we have x minus 4. And on the right-hand side, we have 12. Okay. And if we need to solve for x, we will take the positive and negative square roots of 12 and then add 4 at the end. So this was my moment of understanding completing the square, because now I realize that, oh, we want to create what? We want to create a perfect square. What do? We have the power to do something. We have the power to add a number so that we have a perfect square. And we are going to see plenty of chances to utilize this wonderful skill. And will we see this in calculus, this completing the square? Yes, we will. Okay, if you're taking calculus AB next year, you will probably see it a few times in the second semester. Okay, so don't let this wonderful skill go away.